statement of the theorem. So the statement says that the length of a tangent drawn from the external point to the circle are equal. So this is a theorem. So what is given? Here the center of a circle is 0, where the circle is given with the center of circle 0, and P is an external point, and from P we are drawing two tangents, which is PQ and PR. So I can say that PQ and PR are the tangents. Now we can join OQ, OP and OR. Okay, so this is a small construction we did. Now what we need to prove? We need to prove that PQ is equals to the QR. The tangent should be, the length of a tangent should be equal. That's what we need to prove. So let's do the proving. For this, I'm going to consider the triangle, which is triangle OQP and triangle ORP. Here if you observe, we all know the radii and the tangent would be perpendicular, which we already proved in the previous theorem, right? Since they are perpendicular, the angle would be 90 degree. So I can say that angle OQP is equals to the angle ORP, which is 90 degree. The reason is the same thing, where the radius drawn at the point of contact is perpendicular to the tangent. Then if you observe, PO is common for both the triangles. So I can just say PO is equals to the PO because it is a common side, right? Yeah. And if you observe, OQ and OR are the radii of the same circle. Since both are the radii of the same circle, of course the length would be same. So I can just say OQ is equals to OR. The reason is radii of the same circle. Now from all these conditions, I can say that triangle OQP is similar to the triangle ORP based on the RHS congruence theorem. So from this I can say that the length of the two tangent would be equal, or I can say that PQ is equals to the PR. So this is the theorem. So this is about the lesson circle. In the next class, let's see some more interesting lessons and the topics.